All right, I know that we've done some really long examples in this section, but real quick, I just want to do sort of one more um, where we won't work through all the steps because I'm sure that watching me do algebra is something that is really hard to pay attention to. But we're just going to kind of talk about setting up one more. So we're going to look at y double prime minus 10y prime plus 25y equal to x squared e to the 5x. And what I'm going to do is the rest of these, I sort of gave you y1, y2 at the start. This one, I'm going to sit down with this equation and work through it the way that you would start to finish. So first, I would solve y double prime minus 10y prime plus 25y equal to 0. The reason is because I'm going to need y1, y2 in my general solution eventually, and because what y1 and y2 are might change what my y sub p looks like. So I'm going to say y equal to e to the mx, y prime equal to m e to the mx, y double prime equal to m squared e to the mx. So what I need to have is 0 equal to m squared e to the mx minus 10m e to the mx plus 25 e to the mx. And that gives me the equation m squared minus 10m plus 25 should be equal to 0. And I could go ahead and solve that with like a quadratic formula, but I'm also happy to factor it. That's just m minus 5 squared. So I find that m is equal to 5. So my y1 is e to the 5x. And since I only found one root, but I need two solutions, I know that y2 should be x e to the 5x. I went through that a little bit quickly, but it's something that we worked on last class, so hopefully the steps felt familiar, even if it would have taken you a bit longer to do the multiplication and the factoring and all that. Then I want to find my y sub p that satisfies the entire differential equation. And so for that, I would say, okay, my g of x is x squared e to the 5x. And so my y sub p is going to, by premise A, have x squared e to the 5x in it. And then by premise B, it should have all derivatives. So bx e to the 5x and c e to the 5x. So actually what I'll do is I'll put a little a right there and a little b right there, so you know where they came from. First, I looked at g and I saw what function should be there. Then I looked at that function and included all its derivatives. And then my last part is I check against y1 and y2 to make sure that everything in y sub p is new to me. And it turns out that it's not. So e to the 5x and x e to the 5x were already included in the fundamental solution set. So what I need to do is I need to multiply by powers of x until I create new things. So if I add on a power of x right there, it's the same as before. So what I'd better do is add on 2 powers of x. Now I have a new function right there. If I add on a power of x here, it's the same as y2. So then if I add on another one, it's the same as y sub p. Another one, still same as y sub p. So I have to go up to cx to the 4th e to the 5x. So let's do little arrows right there and say that those came from premise C. Hopefully when you're reading over those notes later, like that seems clear to you. Maybe stop, make a note to yourself, make sure that you understand where every part of this y sub p came from. And so what you would do from here is you would just plug into the ODE. So you would say, okay, I think y sub p is a x squared e to the 5x plus bx cubed e to the 5x plus cx to the fourth e to the 5x. Oops. Don't know what I did there. And what I want it to do is to satisfy, where's my differential equation again? Y double prime minus 10y prime plus 25y. Oops. All equal to, oops, x squared e to the 5x. And all of the derivatives here are going to be really messy, so I'm not going to work through this problem start to finish, the other ones, like showing you all the algebra. Instead, what I'm going to tell you is that this would involve taking derivatives, to get y sub p prime, y sub p double prime. You're going to again have that the e to the 5x all drop out, and you just group your x squared, x cubed, x to the fourth, x and 1 terms together. You know, solve system of equations. All of that is stuff that I know you could do. I know you don't want to watch me do it again, especially when it would take you over the length that lecture videos are supposed to be. But you would find from those equations that A is 0, B is 0, and C is 1/12. And so your general solution, y equal to c1y1 plus c2y2 plus y sub p, is y equal to c1 e to the 5x plus c2x e to the 5x plus 1 over 12 x to the fourth e to the 5x. And the important takeaway here is that that x to the fourth e to the 5x was the last thing we added onto our differential equation. The thing that we started with was x squared. The extra bits we got from the derivatives were x and 1 e to the 5x. And then we had to add on powers to create new functions. And if we had forgotten to do that, we never would have had the x to the fourth appear, and we wouldn't actually have the particular solution, which ended up being that highest power. So you just can't forget to go through A, B, and C when you're building the shape of y sub p. So that was a pretty long example, even though we skipped all of the algebra and calculus that went into it. But I think it was an important one because forming this y sub p is the tricky part of this method. And if you don't do it right, you won't find the true solution. Next up is our wrap-up video. Thanks for sticking with me through all these really long examples.